Could we actually build a real lightsaber from Star Wars? A glowing blade of energy that extends from a small handle, slices through metal, clashes with another lightsaber, and somehow stops at exactly the right length. And chances are, after watching Star Wars, you have picked up a stick, a broom, or a flashlight and imagined it was one. Because the lightsaber is not just one of cinema's greatest weapons. It is one of the coolest objects ever imagined. But could physics actually make one possible? To answer that, we first need to ask what a lightsaber would actually have to do. A lightsaber needs to do 5 things. It needs to create a blade of concentrated energy about a meter long. That blade needs to be able to cut through extremely tough materials. It needs to stop at a fixed length instead of continuing forever. 2 lightsabers need to be able to clash against each other without simply passing through. And finally, the whole thing needs to be handheld and portable. The challenge is finding something that can do all 5 at once. So, what could a lightsaber blade actually be made of? The most obvious answer is a laser. Lasers are real, powerful, and genuinely dangerous. Industrial lasers can cut through metal with incredible precision. Military laser systems can damage drones and other targets. So at first, a laser blade sounds like it could work. But there is one basic problem. A laser beam does not naturally stop after 1 meter. In open air, a laser keeps traveling until something absorbs it, scatters it, or blocks it. If your lightsaber was just a laser, it would keep going past the target, into the wall, the ceiling, or anything else in its path. The second problem is that light beams usually pass straight through each other. 2 lightsabers clashing is one of cinema's most iconic images, but 2 laser beams would simply pass straight through one another without any interaction. So pure laser light does not work. It does not naturally stop at a fixed length, and it does not behave like a solid blade. Which brings us to the more promising candidate, plasma. Plasma is often called the 4th state of matter, beyond solid, liquid, and gas. When you heat a gas to extreme temperatures, electrons separate from atoms, creating a superheated, electrically charged mixture of particles known as plasma. The same state of matter found in the sun and lightning. So, could we use plasma to build a real lightsaber? Not quite. The biggest problem is containment. Plasma expands, it flows, and it reacts to electric and magnetic fields. It is not a solid object that can simply hold its shape in the air. To contain plasma, you usually need powerful magnetic fields, the same basic principle used in fusion research. In fusion experiments, scientists try to hold extremely hot plasma without letting it touch the walls of the machine. But those systems are large and complex. They need powerful magnets, cooling systems, control systems, power supplies, and extremely precise conditions. Now imagine trying to fit that kind of plasma control system into a lightsaber handle. That's simply not possible with today's technology. Even if we solved containment, plasma would still have another critical problem: clashing. 2 plasma blades would not naturally behave like steel swords. They might mix, distort, or repel each other through magnetic fields depending on how they were contained. But they would not automatically create the clean, blade-against-blade clash we see in the movies. So ordinary light fails because it keeps traveling and does not normally clash. Plasma gets us closer because it behaves more like the kind of blade we'd expect. But it is extremely difficult to contain and still does not naturally behave like a solid blade. At this point, it might sound like we are completely stuck. But the science is more interesting than that. In 2013, researchers at Harvard and MIT worked on an experiment where photons, particles of light, behaved in a very unusual way. Normally, photons pass through each other without interacting, but by sending weak pulses of light through an ultra-cold cloud of atoms, the researchers created conditions where photons could influence each other through the medium. This produced something called photonic molecules. In simple terms, light was made to behave a little less like ordinary light and a little more like interacting matter. The researchers themselves compared the idea to lightsabers. Now, to be clear, this was not a lightsaber. It was not even close. It happened in a laboratory under extremely specific conditions that are nowhere near portable or practical. But it does show that the idea of lightsaber isn't as impossible as it might seem. Then there is the power problem, which might be one of the most ignored impossibilities of a lightsaber. To create a blade hot or energetic enough to cut through metal, you would need an enormous amount of power, and that power source would have to fit inside a handle the size of a flashlight. It would need to deliver that energy quickly, control it precisely, manage the heat safely, and avoid harming the person holding it. Current battery technology is nowhere near that level. Even if you had a blade design that worked, powering it from a handheld device would still be a massive challenge. So, can we build a real lightsaber right now? In the Star Wars sense, no. We cannot make ordinary light stop after 1 meter. We cannot make it behave like a solid blade. And we definitely cannot fit the required plasma control system and power source into something the size of a flashlight. Maybe one day, future technology will solve some of those problems. But for now, a real lightsaber remains outside our reach. Which means, for now, you'll just have to pick up a stick, a broom, or a flashlight, and imagine it's a lightsaber.